Hello, welcome. Let's try to solve another Leetcode problem. 853 car fleet. So there are n cars at given miles away from the starting miles 0, traveling to reach the miles target. So let's just use an example. So maybe we have a car. Yeah, let me just use maybe the first example. Maybe we just need to take a few numbers, maybe just 5, 8, and 10. So we're going to use those three numbers to explain what kind of a method we're going to use to solve this kind of a problem. So for the position, we're going to use position 5 and position 8 and position 10. And we also have a speed. So at position 10, the speed is going to be 2. At position 8, so the speed is going to be 4. At position 5, so the speed is gonna be 1. Yeah, and this is the target. So the target is gonna be at position 12. So we are going to calculate how many fleets do we have, but we only have like three cars, and it is always dependent on the speed. So for this car, the speed is 2. So it means after 1 second, this car gonna reach here at the target 12. And but for the second car, so the speed is 8. It means after 1 second, for the second car, it's gonna reach the target here. Yeah, it's gonna be the same position. So it means those two cars gonna become a fleet. Yeah. Now let's just check the third one. So for this one, as the speed is 1 and the position is 5. Yeah, it means after 1 second, this car is going to be at 6. So how many seconds do I need to get this car to the target? So it is 12 minus 5, it is 7 seconds. Yeah. So it means for this example, after 1 second, those two cars will be here, but another car will be here. Yeah. So this is after 1 second, the position is going to be 6, and then after 6 seconds, the position is going to be at target. Yeah, but for those two cars, it has already reached the target. It will go further. It means there will be two fleets. But exactly how can we solve this problem? Yeah. So no matter how it goes, all the cars will go one direction. It will always go to the right, but the speed is different. So for the first car, if the first car the speed is slower, reach to the target. But if the second car here, the speed is faster. Yeah, but before they reach the target, the first car is slower and the second car is faster. Maybe they maybe they will meet at this position, but just before the target. So this is the target. So this means those two cars will become a fleet. Yeah, but what if there is another car, but we don't know the speed of the third car? Yeah, so if the speed of the third car, yeah, but at some point those two cars will be merged at this position. It will become a fleet. But here we have a speed. Maybe we're gonna call it A. So the speed is gonna be A. But here we have another car. The speed is gonna be B. Yeah, but this A actually comes from here. Because this car is faster, this car is slower. Maybe this car's speed is C. So those cars become a fleet and the speed is going to become A. It is just because the speed of this car is faster and this is slower. So we're going to always choose the slower cars. And for the next car, this B, we don't know the speed, but this B is going to compare with this A because those two cars has already become a fleet. Yeah. So if the speed of this car is faster, if this B is bigger than A before they meet at the target, yeah, maybe somewhere else. So it means this car will be merged with this car. It's gonna become one fleet. But if the speed of this B is less than, yeah, if it is less than A, it means it's gonna never merge with this car. This car, it's gonna become two fleet. Yeah, so what kind of data structure can we use to solve such kind of problem? It means if they are neighbors, we're gonna always check the speed. If this is faster, this is slower before they meet to the target, it means they're gonna become 1. And this one also it's gonna become 1, and this one also it's gonna become 1. So the data structure is gonna be a stack. So we can use a stack to solve the problem. And similarly, we can use this example. So for here, after 1 second, it goes to 12. So first of all, we're gonna check this 12 minus 10. So the distance is gonna be 2, and the speed is gonna be 2. So 2 divided by 2, it is 1. It means after 1 second, I'm gonna reach to the target. And for this one, it's the same. So 12 minus 8, it is 4. 4 divided by 4, the speed, it's gonna become 1. It means after 1 second, I'm gonna reach to the target. Yeah. So if this is so the time is for the second car is less than or equal to it's less than and equal to the first car, this 10. It means they will merge somewhere before the target or equal to the target. And let's compare the third one. So this one, 12 minus 5, 7. 7 divided by 1, it is 7. It means after 7 seconds, I'm gonna reach to the target. It means that this 7 is bigger, and the 7 is bigger than 1. So it means it's gonna become 2 fleet. If this is not 7, maybe 0.5. Now it's gonna become 1 fleet because it must be somewhere before 12 or equal to 12. They will become 1 fleet. Yeah, so this is the idea of how to solve the problem. Now let's just use this kind of idea to solve the problem. So let me use a time array. It's gonna be inside. It's gonna be a tuple. Yeah. So inside, I want to have the time for all the cars to reach the target. Yeah. But I'm gonna sort it according to the position. Yeah, I'm gonna sort it according to the last position to the first position. It means the first one gonna be 10, and then 8, and then 5, 3, and 0. Yeah, so I'm gonna use a target minus the position and divided by speed. So it's gonna be the time for the last position to reach to the target, and for position, speed, in zip, position, and speed. Yeah, but for this one, it's gonna be a sorted zip, so I'm gonna use a sorted, and it's gonna be sorted in reverse order, so the reverse gonna be true. Yeah, so after this one, I'm gonna have a time array, and inside it's gonna be a and inside it's gonna be the time to reach to the target from the last position to the first position. So for example, this 10 gonna be the last position, this 8 may be the first position, and 12 is the target. So here I have a time of 1 for the speed of 2. Here for the speed of 4, I have another time of 1. Yeah, and then I'm gonna check it by using the stack. I'm gonna check the first one because currently it is already reversed in reverse order. So I'm gonna check the first one and then the second one at position 8. Yeah. Now I'm gonna prepare a stack. So for t in time, I will first put it inside the stack. Now I want to check the length of the stack. So if it is more than or equal to 2, it means there will be 2 cars. I have to check if they can become 1 fleet. Yeah, so if it is less than or equal to 2, and stack minus 1 is less than or equal to stack minus 2, so it means I need to pop it out. Yeah, because in between it doesn't matter, I just need to pop it out, and after that I just need to return the length of the stack. Yeah, so the idea is that, so for example, this is 1 car. Yeah, I will first put it inside the stack, but I will put the time. It's gonna be a time of 1, and then I'm gonna put this car inside the stack. The time gonna be 1 as well to reach the target. Yeah, and then I'm gonna compare. So this is the stack. This is the stack minus 1. This is the stack minus 1, and this is the stack minus 2. Yeah, so as this minus 2 actually this is at position 10, but this one, this minus 1, it is at position 8. Yeah, because this one, the time is less than and equal to, because this is minus 1, because this time 1 is less than and equal to the stack minus 2, so this is minus 2. So it means this one doesn't matter. I need to this means this one doesn't matter. I need to pop it out. It means at position 8, this one doesn't matter. I need to pop it out. Yeah. Maybe we have another one. Maybe at position 5. If we have a speed of 1, it means the time gonna become 7. So this one gonna be popped out, and then I'm gonna put 7 inside. Yeah. But the stack minus 1, as you can see, this is minus 1. Is more than the stack minus 2. This 7 is more than 1. It means I take more time to reach the target. It will never become a fleet. So I will just put it inside of the stack. It means the length of the stack is going to become 2. So I'm going to return 2. But what if the speed is maybe, so here the speed is 1. So maybe the speed is 10. Yeah. So it means maybe after, yeah, so the speed is 10, and 12 minus 5 it is 7, 7 minus 10. So it means after 0.7 seconds, I'm gonna reach the target. So this one gonna be 0.7. Yeah, so this means the stack minus 1, this one, for the last car is less than or equal to the stack minus 2, less than or equal to this car. It means they will become a fleet. So the stack gonna pop out this one, yeah, because this is shorter. But finally, it will take the maximum time. It's gonna become this one. Yeah, maybe there's another one, maybe 0.5. So I will just pop it out, and the time gonna become 1, because it will always choose the slowest speed. It means the biggest time. So it's gonna be this time. Yeah, so this is the idea of how can we solve it by using a stack. But before that, we need to use the sorting. So the time complexity gonna be n log n. Now let me just run it and submit it to check if it works. Yeah, as you can see, it works and it's pretty fast. Thank you for watching. See you next time.